Hello friends, welcome to your only channel Times of Coding. Today in our series Scala Express, we will learn about Scala Futures and Concurrency. This session will help you to understand Scala Futures and Concurrency programming. In previous session, we have understood XML structure, how to write XML structure, and how to read XML with the help of Scala language. In this session, we will learn about asynchronous transformation, how to create futures, and how to work with Scala Futures. Scala Futures offers one way to deal with concurrency that can reduce and often eliminate the need to reason about shared data and locks. And these locks, if you are coming from the Java imperative background, you might have experienced that lock can be tricky to handle at times. When you invoke a Scala method, it performs a computation while you wait and return the results. If the results is a future, the future represents another computation to be performed asynchronously, often by a completely different thread. As a result, many operations on future require an implicit execution context that provides a strategy for executing functions asynchronously. In this example, we will define one future. So here I'm creating future with the help of braces. First I'm applying thread.sleep for 100 milliseconds and then we are returning 21 plus 21. That means the result of this computation will store in fut variable. And these are the two classes which we need to import for implicit global execution context, and this is to concurrent future class. Okay. Now there are two methods on future allow us to poll, which is completed and value. When we invoked is complete, it will return the status if this computation has been completed inside the future body. So here after execution we are getting false. That means we are executing this statement before 100 milliseconds here. And this time the value will be none. You see, this is an option type, so it will be none. So the value we will get out of fut.value will be kind of options of try of int. And after that sleep period completes, you will get is completed as true and fruit.value as sum of success of 42. Sum for option, success for try, and 42 is the computation result. Value gives result as a try, that means it will serve value with success or failure. Failure you will see in case of exception. So here we are defining multiply by 0 and here I am keeping 1 millisecond sleep. So as soon as we execute this, it will be ready to serve the value. And then we are having check is completed, which is true, fut.value, which is having exception type of arithmetic exception because we were dividing by 0. So here if you see the type sum of failure and earlier it was sum of success. So this success and failure is coming from this scala.util.try. The same future we can transform with map also. Now since map, we have already seen that it used to iterate all the elements inside the collection. So here fut.map I'm writing, then we have got one function which will have addition of 1. Whatever value we will store in this fut collection. And then we are writing a statement to get the value. So here after execution we will have future not completed. We will have value result.value which is 43. You see earlier it was 42 here and now it is 43 because it is coming after plus 1. Okay, to work with for loop we can do like, first we need to define some futures and here I'm defining two, fut1 and fut2. And then we are creating one variable which is holding a reference to for loop And in that for loop, we are taking all the future 1 value into x and future 2 value in y. And then we are yielding value x plus y. So fut1 will have value called 43 and fut2 will have value of 45. 43 and 45, we should have 88 with this yield statement. And to access that value, we are typing res dot value here. So as we expected, we are having 88 after summation of these two futures. The type we are having is fut1 type of scala.concurrent future int type, and then future not completed, it has declared inside. Likewise, we have got 3 variables which is holding some future value, and to access the future value, we are applying this function here to get option of try of value. Beside the apply method used in earlier example to create some futures, the future companion object also includes 3 factory method for creating already completed futures, which is successful, failed, and from try. These factory methods do not require an execution context, so we don't need to import anything which we were importing earlier except the future class. So now here we are directly creating future.successful. We are writing 21 plus 23 in the braces, and then we are defining again one statement with future.failed call, and here we are keeping one new exception called stuck as message. Okay, so here we are importing success and failure from scala.util package, and then from try we are keeping success for this statement and failure for this statement. You see, failure, new exception is stuck. When we execute this statement, we will have first the successful 44, then we have failed with exception with message stuck. We are importing, then we have got 44, 21 plus 23, and then we have got exception again. So that's how we can use even companion object of future. Okay, keeping a promise, we can obtain a future that is controlled by the promise. The future will complete when you complete the promise. So it's kind of condition, you can say here. So first we are having promise of int type, and then we are declaring promise.future and then future.value. Since we are not defining anything here, so future.value will get us none as we expected. Now future can complete the promise with methods named success, failure, and complete. These methods on promise are similarly to those described previously for constructing already completed futures. So promise.success, if you call with 44, you see, because here you have made a promise type of int. So promise.success, if you write 44, you will get future.value as sum of success 44. Scala Future offers 2 methods, filter and collect, that will allow you to ensure property holds true about future value. The filter method validates the future results. Let's see how. So here we are defining one future value 42, and then future.filter we are doing, and here we are writing condition greater than 0, and if this matches, then we are writing valid.value. Valid variable will have value after this filter condition. So since this 42 value is greater than 0, we will have 42 here, and which we are having after execution also here. After that, we have collect function where we used to validate the future value and transform that in one operation also. So here we are having valid dot value, which was giving us 42 value. On this we will apply collect, and here we will have case of result. If res greater than 0, then res plus 48. So 42 we are already having. If this valid value matches with this condition, it will add 48 more. So here our result.value will become 90 now. So after execution we are expecting same. That's how we apply transformation inside the collect. And filter we have already seen. These two functions are very important functions. In fact, when you work on some real programs, you need to remember these two functions basically. Otherwise the future will fail. If this condition doesn't match, then success will become failure in this future statement. So this is an example of failure statement after the collect execution. Valid collect, here we are changing the condition. Earlier we were having greater than 0, here we are having less than 0. So obviously it will not get fulfilled. So this will not get execute, and result.value will have exception here. The exception type is future sum of failure of Scala concurrent future. Okay, future collect partial function is not defined at 42. So whatever function we were writing here, that is not defined to work with this value. This is what it is making sense. Dealing with failure, we have got fallback, recover and recover with method, and that we use like failure.failed, and here expected failure.value we are writing here. So failure.failed will get you the exact exception. Now the expected failure.value, if you retrieve, you will have sum of success because it was expecting failure only and it has got failed. So this operation will get success. That's why we are having sum of success java.lang.arithmetic exception divided by 0. So here we have got another function called fallback2, and fallback2 will be applied on expected failure dot fallback2, and then we are passing some value in it. This will also get us same result, which is type of future of any, and here also we will have similar exception because our value is same. Okay, then we have got recover. So recover is basically to recover the expected failure. Now here we have got value recovered, expected failure, then recover function. Here we are having case matching. So if this case matched with arithmetic exception, this will get us -1. Okay, so we are writing recovered the scala.concurrent.future type of any, and here future of success we have got as arithmetic exception. When we retrieve value out of this recovered, we will have try of any, and here sum of success, and it will get us exception. Now then we are having recovered with function, and this is very important function when you deal with failures, and I will explain how. So here also recovered, we are having failure here. This failure is one of the value which we have already seen. This recover with we need to apply on failure. Failure could be any exception, and inside this recover with you will have your case matching, and on basis of case matching you will write future. You see, earlier we were having all these value as exception because these were not having future type of value. So now we need to write future instead of -1. If you see the immediate above example also, here we were writing -1, and when we try to retrieve value with recover.value, because it was not future, so it has given exception to us. Now we will write future only with 42 plus 46, and this time when we have also recovered, which was the variable where we have done all this operation, this was the variable who hold this statement's outcome, it will get us the value, and the value type will be sum of success of 88. 42 plus 46, 88, as we expected here. So that's how we can deal with failures. The recover method allow you to transform a failed future into successful one, where recover with is similar, except instead of recovering to a value like recover, recover with allows to recovery with future value, not just integer type, and that's why we have written future.42 plus 46 there. Now transformation of future may end up as success and failures. So let's map both possibility with transform method. And here we will map success condition with this function. So we are having some fut. We are applying transform function on this. Here we are keeping one operation with the successful condition. Rest multiply by -1. And if it is not successful, then we will be having one exception matching criteria here. If this exception matches with C cause type, it will throw us this exception. Okay, let's see both of the result now. So first dot value we will see, which is type of sum of success -42 as we expected. Now if you declare instead of fut here, because earlier we were taking fut which was having a value of 42. Now we will write failure here, which is having exception scenario. So in that case, this exception will match and we should have this exception now. So when we are retrieving first dot value, we have got sum of failure, java.lang exception, and in message C cause, which we have defined here. Likewise, it gives many functions from its companion object as zip, future.fold, future.reduce, future.sequence, traverse, and to perform side effect we have got for each, on complete, and then. With few new methods also we have got as flatten, zip with, and transform with, which I will let you explore by yourself. So in theory we have completed today's session. Now it's time to do some practical. Okay, so we have started IntelliJ, and this is the first example we have seen today. So here I will apply 100 milliseconds, or let's say 10 seconds, and I will do this computation. You see, is complete is false because we have not passed 10 seconds and it is giving none as value. Now I will change this value to 10 milliseconds. You see, is completed gave us true, and value we have got sum of success as 42. So after this example we have seen how to use map with future value. So future we have already declared as fut variable, so we will use the same variable name only. Here we are defining map function, and in that map function whatever value we are having in this fut, we are adding 1 here. So let's run it. Okay, so this is the future basic syntax you will get familiar with going forward, because whenever we need to retrieve future value we need to type dot value function, otherwise it will not throw any value to us. That's why it is getting not completed. And when you retrieve value with dot value function, you will get sum of success of 43 as we expected. Okay, after this example we have seen how to work with for futures. So here we are declaring two futures, fut1 and fut2. Both I'm keeping in x and y, and then we are yielding this operation value as x plus y. So in x we are getting fut1 value which is 43, and in y we are expecting fut2 value which is 22 plus 23, 45. Okay, after this we will have yield x plus y, which will add 43 plus 45, that means 88. So this value should get us 88. Now let's run it, and you see, as we expected, we are getting sum of 88. The next example we have seen is about to retrieve value for future.successful and failure as failed. So here we are keeping one operation which is just an addition, and here we are keeping one exception with message called stuck. So when you define like this, you will get a straightforward message that future.int type, which is rest 0, because we have not defined any variable here, holding a value of 44 as output from this operation, and future.failed will get us value future of failure type, and exception and stuck is the exception message as we have passed here. So that's how you can define successful and failed cases while using future in your Scala program. Okay, the next example we have seen, which was from try. So here what we are doing is future.from try, and then we are defining successful and failure condition. So let's see what this statement will get us. Okay, so here success and failure got imported, and then future.success will get us 44, and this will get us future of failure type of exception message stuck, same as we expected earlier also by defining them directly. Okay, so this is how you can define from try, and this is how you can define directly also. Both will give you same outcome. Okay, so we are defining promise of int type in this promise variable, and then we are assigning promise.future in this future variable, and then we are trying to retrieve future.value. But this time we have not assigned any operation or any value. This should get us none, and after execution we are getting same. And here we are keeping success of 44. Since it is int type, promise will be fulfilled with this value. So future.value should technically get us 44. So that's what we are getting after execution here. You see, sum of success of 44 as we expected. And here in fact same is getting assigned in promise.type, which is success of 44. Okay, so after this example we have seen filter and collect condition. First we are defining future with random values as 44 here, 42 here, and then I am assigning filter condition which has greater than 0 condition. If it is true, then we will have valid.value. Likewise we are having collect conditions also, and this is the successful condition where we are expecting this result value should be greater than 0, and if this condition matches we will add 48. Now here it's a failure situation because we are expecting result less than 0. So we will see how it will behave on the basis at times of failure. Both the times we are having collect, and here we have got filter. So filter expect this condition to be true to filter the value, collect expect this condition to be true to collect the value. Okay, so let's run it. Okay, fut22 here, valid here, and valid.value 42 as we expected because we have given 42 here. Now this is a successful scenario, so this result should have 42 plus 48, 90 as we expected. You see, now this is failure scenario, so here we should have some exception. Sum of failure concurrent future, future.collect partial function is not defined at 42. All right, then after this we have seen how to tackle failure condition. So for that we have seen 4 functions, which is failed, fall back to, recover, and recover with. So these all 4 functions we will see how it behaves, and in theory we have already discussed what is what. So without wasting time I will execute it, and you see failure we are defining here, failure is coming here. Okay, since it is divide by 0 we should have arithmetic exception, so here we are getting arithmetic exception. Now the next variable we are defining expected failure, which is here. Okay, so since we are operating failed function on failure value, so it should obviously get us arithmetic exception. Okay, then next we are having fall back to. So fall back to is having one value called valid, and then we are trying to retrieve this fallback dot value, whatever value it has processed here. Okay, so this will also get us divide by 0 arithmetic exception as we are having here. Okay, then we were trying to recover. So recovered means expected failure we have already seen as arithmetic exception. we're trying to recover, and inside that recover body we are giving match cases, and if this matches with arithmetic condition, which is the condition now, it should get us -1, and then we are trying to keep -1 value, and then we are trying to retrieve -1 value as a recovered dot value. Okay, so here recovered has got same as we expected, and when we try to retrieve value, it is getting us nothing because this is not a future value. Okay, one thing to remember here, since we are keeping -1, not the future of -1, this value cannot be retrieved even by just making a call to recovered, because recovered is store a value of future time. Okay, so here by default we were getting it, and sorry, after recovered is here, and after this these two statements are coming from these two statements here. Okay, so we cannot retrieve value out of this recovered dot value or recovered statements because recovered variable is having a value of future type. Okay, and in future we have got exception, so always we will get this exception only. Then we are having also recovered variable here, output is here. Okay, so future not completed as we expected, and in this value, since it is also matched with this arithmetic exception, this should have successful future value here. So we are getting success of 88 as we expected after 42 plus 46. After this we are having first, which is transformed operation call, we are calling here. So first variable here, and after transformation call we are giving two conditions here, one for successful, one for failure. Okay, if this failure will hold a value as success, this statement will work. If this failure holds a value as failure, as we know already it is, so it should get us this exception. Now when we will write first dot value to retrieve value from this statement, we will have sum of failure of exception C cause because we have given this message here. Okay, now our successful instance was also recovered, so if you type this also recovered instead of failure, and if you write likewise and if you execute again, see you are having -88. Why you are having -88? Because for successful future value you were doing multiply by -1, so likewise we have received -88. With this example we have completed today's video content. I hope you like this content. Thanks for watching. Happy learning.